The first problem on this fourth formative assessment of our term is a solving rational equations problem. And it says to find all the real solutions to this equation and to justify each step. And then identify any extraneous solutions and explain why they are extraneous. Well, here we are with a rational equation. It's rational because it has a set of 3 rational expressions in it, actually. And a rational expression is any polynomial divided by any other polynomial. This one, of course, is just x divided by 1, which turns it into a rational expression. So the first thing you should notice about this problem is that we need a common denominator, and that common denominator is 6. So what I have to do is make sure that each of my 3 rational expressions has a denominator of 6. So the one here on the left, I can just multiply the top and the bottom by 6. The first expression on the right-hand side, I just bring down as it is because it already has a denominator of 6. And then this final rational expression, in order to make this 2 a 6, I need to multiply it by 3. And if I multiply the bottom by 3, I got to multiply the top by 3. So I get this, and that is find a common denominator. Now, if I multiply both sides of this equation by 6, that's the same as multiplying each of my 3 terms by 6. And if I multiply this first term on the left-hand side by 6, the 6 on the top and the 6 on the bottom will cancel out, and I'll just be left with 6x. If I multiply this term by 6, then I would get a 6 on the top, and it would cancel with the 6 on the bottom, and I'm left with this. And then, same thing for the final term. So really, I used the multiplicative property of equality here. I multiplied both sides of my equation by 6, and that just eliminated my denominator. So now I have this quadratic equation in terms of x. So I can solve this, and typically when we solve quadratic equations, the first thing we want to do is write them in standard form, all on one side of the equation, and have the other side of the equation equal to 0. So first, let me deal with these parentheses. Minus 18. So I distribute the 3. So this is the distributive property. And then I can subtract 6x from both sides, and I get 0 equals x squared minus 3x minus 18. And that's from the subtractive property of equality. Equality. So now I have a quadratic in standard form on the right-hand side of my equation, and it equals 0. So if I can factor this thing, that's my first move. If I can factor, I'm just going to factor and use the zero product property. If for some reason I just can't factor it, maybe I go back and look and see if I made a mistake, or I use the quadratic formula. But I think you might have already seen how this factors. X minus 6 times x plus 3. So I factored. And in my mind, I just multiply this thing back out and make sure that I got this. Okay? X times x is x squared. I get a negative 6x and a positive 3x. Those combine to make a negative 3x. And then negative 6 times 3, negative 18. Just do that in your head real quick, just to make sure you didn't make any sign errors when you factored. And so now I can say x minus 6 equals 0, or x plus 3 equals 0. And I can do that because of the zero product property. And then I can use the properties of equality really easily. Add 6 to both sides. And the other one gives me, if I subtract 3 from both sides, I get that. And that's from the, I'll just say the properties of equality, because I used the additive property here and I used the subtractive property here. So just being general. And those are my solutions. Those are the values of x that make this equation true. And in thinking about extraneous solutions, notice that what causes extraneous solutions is that if there's any values of x that would cause the original equation to be undefined, and then somehow along the way I ended up with one of those values as my solution, as one of my x values in my solution, then that would be extraneous. There's no way to cause division by 0 in this expression but with any particular value of x. No matter what x is, we're always going to be dividing by 2 here and dividing by 6 here. And if you want to think about dividing by 1 here. The denominators are not in terms of x. So there's no values of x that will cause this original expression to be undefined. So there's no values of x that are going to result in extraneous solutions. So I might just say no extraneous solutions. And that's the end of the problem.